Hello everyone. Today we are going to look at the concept behind numerical integration. So this is the video in which I'm going to explain the concept behind numerical integration. I'm not going to solve any problems. I'm going to solve problems in the next video. So people who are interested in the concept behind numerical integration, I would highly recommend that you please watch this video. And it's going to be a very slow video. I'm not going to race through the concepts. I'm going to take it very slowly. I'll take some time to lay the groundwork. Okay, so to begin with, let us consider a function f of x, or maybe I would say f of epsilon. Okay, f is a function of epsilon. So I will draw the function f along the y-axis and the function epsilon along the x-axis. So f is the dependent variable, epsilon is the independent variable. So here we go. This is epsilon, this is f. It's perfectly fine if you call this epsilon x, or in some textbooks for numerical integration they use the notation or. It's perfectly fine. It doesn't really matter what you call this. Okay, we are just going to consider a function. Okay, and let me draw the curve. As you plot this function, let us say that the function goes this way, and I'm going to write the equation for this function. Let us say that the equation of this curve is f, which is a function of epsilon, is equal to a0 plus a1 epsilon plus a2 epsilon square plus a3 epsilon cube, and so on and so forth, right? It just keeps going. Maybe I can add just one more term to this, a4 epsilon raised to the power 4, and it just goes on. Now we are going to integrate this function between the limits -1 to 1. You may ask me this question, why specifically between the limits -1 to 1? Because in finite element analysis and isoparametric elements, the limits are between minus unity to plus unity. So that's the reason why we're actually going to integrate between the limits -1 to 1. So you have to look into the concept of isoparametric elements in order to truly understand why the limits are always going to be between -1 to 1. So let me indicate the limits here. It is from -1 and it goes all the way up to +1. Okay, and I'm going to integrate this function. You know very well that if I integrate this function, what I will get is I will get the area beneath this curve that is given by this yellow rectangles that you can see that. Okay, so if you integrate this function f of epsilon, you're actually going to get the area below this curve. All right, so let me do the integration by conventional method. So I'm just going to integrate this function between the limit -1 to 1, okay, with respect to epsilon. Okay, now if I integrate this function between the limits -1 to 1, what is that I will be getting? So I highly recommend that you do this in the privacy of your room, but let me write the results directly. You will be getting 2a0 plus 0a1 plus 2 by 3 a2 plus 0 a3 plus 2 by 5 a4. So this is what you will be getting if you integrate this function between the limits -1 to 1. Okay, it's by Newton's method. There is a video that I have made how integration actually works. I would also suggest that please go and watch that video. In that video I have explained how you get integral of x raised to the power n with respect to dx as x power n plus 1 divided by n plus 1. So how do you actually get that? Okay, now what I will do is I'm just Now this is the result that you will get. Now I'm going to consider another function, which is, I'm just going to consider only the first term alone. I'm going to consider only the first term alone, and I'm going to plot a graph. Okay, so let me do that. So if you take the first term alone, and if you just plot a graph by taking the first term of this function, now what happens is f of epsilon is equal to a naught. I'm not considering any other terms, I'm just considering the first term. Now I'm going to plot a graph. Okay, if I take this function and if I just plot a graph by taking the function f along the y-axis and epsilon along the x-axis, now we know that it's just a constant, so I will be getting a horizontal line, something like this. Now I can also integrate and find what is that you will be getting if the integration is from -1 to +1. So what is that I'm going to get if I just integrate this? I know the result, so integral over the limit -1 to 1 f of epsilon, and you integrate this with respect to d epsilon, and the result that you are going to get is 2a naught. That's not a surprise, but remember that you can also get the result 2a naught by adding all the rectangles. Okay, so what I will do, I'll just construct rectangles like this, and you are going to get this 2a naught by adding all the rectangles. Now what is the length of the first rectangle? This is our first guy here. This is w1. And what is the height of the first rectangle? It is going to be f1. Okay, and you know that f1 is equal to a naught. Okay, it's always going to be a naught. It's always going to be a naught. And what is the length of the second rectangle? Let us say that it's w2, and the height of the second rectangle, maybe we can say that it is f2, and that is also equal to a naught. Fine. And similarly we can say what is for the third rectangle, and what will be for the fourth rectangle, and what will be for the fifth rectangle. It will be w3 f3, w4 f4, w5 f5. You know where the story is heading, so I'm not indicating the f3 f4 f5, just keep it at the back of your mind. So I can also get the area by summing all the rectangles, right? So that gives me an equation. So what is the length, what is the area of the first rectangle? Well, it's w1 f1. What is the area of the second rectangle? It's w2 f2. We know that f2 f1 f2 f3 f4 so on and so forth, everything is equal to a naught. We know that, but I'm just trying to write a very generalized equation here. It's w3 f3 plus w4 f4 plus w5 f5, and that should actually be equal to a naught. Okay, so I can pull all, since f1 is equal to f2 is equal to f3 is equal to f4 is equal to a naught in our case, so on and so forth, that is all equal to a naught. I can just pull all the f's outside, and I can just write this equation as a naught into, because if I just pull all the f's outside and f is equal to a naught, f is equal to epsilon is equal to a naught, so I will be getting a naught into w1 plus w2 plus w3 plus w4 plus w5, so on and so forth, it keeps going, is equal to a naught. So I can cancel a naught on either side. Okay, see, it's not just up to w5. Actually, the general equation is it just keeps going. Okay, now I have an equation. That equation is w1 plus w2 plus w3 so on and so forth is equal to 2. So I'm getting an equation. If I consider only the first term in the function, which is a naught, and if I have to integrate that function, I can say that the integration of that function is going to give me 2a naught, where the sum of all the w's should be equal to 2. So this is going to be my first star equation. Now I'm going to consider the second function alone. I'm not going to consider the first two terms. I'm just going to consider the second term in the function alone. So there you can see that I'm putting a highlighter. I'm just going to consider only this term in the function, and I'm going to do exactly the same. Okay, so let us do this. So the second term is a1 epsilon. So if I plot a graph, the second term, f of epsilon, f which is a function of epsilon, is equal to a1 epsilon. If I just plot a graph by taking the function f along the y-axis, and of course along the x-axis it is just epsilon, which is an independent variable. If I plot a graph, I'll be getting a straight line, and the equation of the straight line is a1 epsilon. So that's what I will be getting. But for time being, what I will do is I will just ignore the a1, and I will just, because it's just a constant anyway, at the end I can just hit it with a1. So for time being, for simplification, what I will do is I will just ignore the a1 terms, a2 terms. I'm just going to ignore all the constants. Anyway, I just don't want to carry those constants with me. So what I will do, I will just erase it, and I will just ignore only the constant. I'm just going to write the function epsilon alone. So I'll be getting, it's a straight line, fine. Now in exactly the same manner, I'm just going to integrate this function. I know what is that I will be getting if I integrate this by exact method. So if I integrate this function between -1 to 1, epsilon with respect to d epsilon, I will be getting 0. Okay, so you may argue this question, that is definitely the area beneath is not going to be equal to 0. But anyway, what I'm interested in doing is I'm interested in the concept. Okay, so maybe what I will do is I will just redraw this graph in case, just to make sure that the graph is consistent with the concepts. Maybe the line goes something like this, so that the positive area and the negative area, they cancel out, so you get the net area to be 0. Okay, so the limit is from -1 to +1. So this is epsilon, this is the function f. Okay, hope that should be fine, I guess. Fine, now I can get the area beneath this curve by populating this curve with, populating this area beneath the straight line with rectangles. So let me indicate that by putting the rectangles, so on and so forth. So you know where the story is heading. The width of the first rectangle is w1. What is the height of the first rectangle? This is the first rectangle. It is f1, and f1 is equal to epsilon, so it will be epsilon 1, the value of epsilon at that particular point. Okay, similarly for the second rectangle, it's going to be w2, and what is the height of the second rectangle? It is epsilon 2, so w3 epsilon 3, so on and so forth. Now I can get the integration result by summing all the rectangles. So what is the summation of all the rectangles? It's w1 epsilon 1 plus w2 epsilon 2 plus w3 epsilon 3, so on and so forth, and that should be equal to 0. So this is going to be my star equation number 2. So this is fine. So you know where the story is heading. I'm just going to consider the third term in the series, which is f of epsilon is equal to, ignoring the constants, it's going to be epsilon square. If I just integrate this term, what is that I will be getting? If I just integrate this epsilon squared, I will be getting 2/3. If I integrate this between the limits -1 to 1 with respect to epsilon, So integrating minus 1 to between the limits minus 1 to 1 with respect to epsilon, I'll be getting 2 by 3. So let me represent the equation of this curve. Okay. Okay, graphical representation. So I guess it should be something like this. The limit is from minus 1 to plus 1, and all you do is sum all the rectangles, and the width of the first rectangle is W1 and the height is F1, and we know what is F1, it's epsilon 1 square. And similarly the second rectangle, it is W2, and what is F2, it is epsilon 2 square. Okay, so now what I can do is I can say integral over the limit minus 1 to 1 epsilon square with respect to d epsilon is going to be W1 epsilon 1 square plus W2 epsilon 2 square plus W3 epsilon 3 square, so on and so forth. That should all be equal to 2 by 5. This is the equation that I will be getting. So let me call that as star equation number 3. Similarly, what is going to be our star equation number 4 and 5? So allow me to write that right away. So star equation number 4 and 5, I'll be getting W1 epsilon 1 cube. Okay, W1 epsilon 1 cube. Okay, this is, okay, just give me a minute. It's not 2 by 5, it's 2 by 3. 2 by 3, I'm sorry, it's my mistake. It's 2 by 3. It's 2 by 3. Okay. All right then. So in exactly the same manner, I can say what will be W1 epsilon 1 cube plus W2 epsilon 2 cube plus W3 epsilon 3 cube, so on and so forth. That should actually be equal to 0. So that's going to be our star equation number 4. So you know that if you just follow the procedure, you're going to get this equation. In the same manner, you'll be getting W1 epsilon 1 raised to the power 4 plus W2 epsilon 2 raised to the power 4 plus W3 epsilon 3 raised to the power 4 plus so on and so forth. That should actually be equal to 2 by 5. So this is going to be our equation number 5. So let us recapitulate the equations that we have to write. Okay, so what we did, we took only the first term, and you just this term, the first term, that is a0, and if you just represent it as a graph, and if you can just rewrite the integration results by the sum of the rectangles, all the rectangles. So you get W1 plus W2 plus W3, so on and so forth, should be equal to 2. And if you take the second term, you will be getting W1 epsilon 1 plus W2 epsilon 2 plus W3 epsilon 3, so on and so forth, should be equal to 0. And for the third term, it should be W1 epsilon 1 square plus W2 epsilon 2 square plus W3 epsilon 3 square, so on and so forth, should be equal to 2 by 3. And for the fourth term, W1 epsilon 1 cube plus W2 epsilon 2 cube, so on and so forth, should be equal to 0. And for the fifth term, it will be W1 epsilon 1 raised to the power 4, W2 epsilon 2 raised to the power 4, W3 epsilon 3 raised to the power 4, so on and so forth, should be equal to 2 by 5. So I think we can stop here. So now I have got 5 star equations. I forgot to put the stars here. So the 5 star equations. Okay. Now what I'm going to do is I'm going to consider, first what I did, I considered only the first term individually, the second term individually, then I considered only the third term individually, the fourth term individually, and the fifth term individually, right? Now what I'm going to do is I'm going to consider the first two terms, Okay, then I will consider the first 3 terms, then first 4 terms. So I'm not going to consider individually, but I'm going to consider the first 2 terms, first 3 terms, first 4 terms, so on and so forth, right? Now let me do that. So in the next step, I'm going to consider the first 2 terms. So f of epsilon is equal to a naught plus a1 epsilon, and we are going to integrate this function with respect to -1 to 1. So what is that? I'll be getting, if I integrate this between the limits -1 to 1 with respect to d epsilon -1 to 1, of course we are going to integrate this with respect to d epsilon. Okay, now you know what is the result. You will be getting 2a naught plus 0a1. So that's the result. But you know what is 2. What is 2? Well, our star equation 1 tells us what is 2. Look here. Look at this equation. Maybe I can indicate a red color. Look at this red box. That is 2. So mathematics is just like moving objects. You take this 2 and plug it over there. I'm sorry, you take this w1 plus w2 plus w3 in place of 2, and you are just going to substitute that. So what I will be getting is, I'll be getting, instead of 2, I can say it's w1 plus w2 plus w3 plus so on and so forth, right? It just keeps going into a naught, and we know that that is 2, right? Plus 0, that can be written as w1 epsilon 1 plus w2 epsilon 2 plus w2 epsilon 2 plus w3 epsilon 3, so on and so forth. That should be equal to 0. So we know that this term should give 0 and this term should give 2. So now the question is, how many w's that you are going to take? What's the value of w1, w2, w3, so that you add them up to get 2. In exactly the same manner, what should be the value of epsilon 1, epsilon 2, epsilon 3, w1, w2, w3, so that you sum these terms, w1 epsilon 1 plus w2 epsilon 2 plus w3 epsilon 3, so that the summation of all these terms should be equal to 0. So the question that you have to answer is w1 plus w2 plus w3 plus w4 plus so on and so forth, that should be equal to 2. So how many w's that you have to take? And also you have to answer this question, what is the value of epsilon 1 and w2 epsilon 2 plus w3 epsilon 3. So how many terms that you have to take? That should be equal to 0. So now we have this burden, and let us start with something that is very simple. That is, let us say that the w1, we will just take one term. Okay, what is the one term that you are going to take, which is w1? If you just take one term alone, then you can say w1 is equal to 2. And also if you take one term here, you can say w1 epsilon 1 is equal to 0. Since w1 is 2, epsilon 1 should be equal to 0. So this is perfectly fine. So all you have to say is, well, to the answer to the question for this particular case is, you have to take only one term. We will definitely come up with a generalized equation, but take my word for it. You just have to take only one term, which is w1 is equal to 2, and w1 epsilon 1 is equal to 0. So that gives epsilon 1 is equal to 0. So the answer for now, time being, just take one term. And if you are taking only one term, the value of w1 is equal to 2, and the value of epsilon 1 is equal to 0. Okay. All right then, fine. Now let us consider 3 terms in the function. Okay, so what I'm going to do is I'm going to consider, look for white color, I'm going to consider the first 3 terms, and we are going to do this equation, right? Let us consider the first 3 terms. So the function is f of epsilon is equal to a naught plus a1 epsilon plus a2 epsilon square, and you are going to integrate this between the limits -1 to 1 with respect to epsilon. Integrate this between the limits -1 to 1 with respect to epsilon, and you know the result. You'll be getting 2a naught plus 0a1 plus know the equation for 2, which is W1 plus W2 plus W3 plus so on and so forth. That should be equal to 2. Okay, fine. So that was our first star equation. The second one is, we know W1 epsilon 1 plus W2 epsilon 2 plus W3 epsilon 3 plus so on and so forth. That should actually be equal to 0. That's our second star equation. So W1 epsilon 1 square plus W2 epsilon 2 square plus W3 epsilon 3 square plus so on and so forth. That should actually be equal to 2 by 3. Okay, fine. So that's our third equation. So again, you have to answer this question: how many W's that you are going to take? Okay, and how many W1 epsilon 1, how many W epsilon square terms that you are going to take? Okay, let us start with something that is very simple. We will take only one term, in which case W1 will be equal to 2. And in the second equation, if you are taking only one term, then you will get W1 epsilon 1 is equal to 0. So this gives us epsilon 1 to be 0. And in the third equation, if you are taking only one term, W1 epsilon 1 square is equal to 2 by 3. Since epsilon is 0, you get 0 is equal to 2 by 3, which is definitely wrong. So taking one term now is not going to be sufficient. So what I will do is, the next logical step is take two terms. So take two terms, in which case you will be getting W1 plus W2 is equal to 2. Take two terms, W1 epsilon 1 plus W2 epsilon 2 is equal to 0. Take two terms, W1 epsilon 1 square plus W2 epsilon 2 square is equal to 2 by 3. Since you have taken two terms, let us solve for the values of W's and epsilons. Now in the first equation, W1 plus W2 should be equal to 2. So what I will do is, I will assume W1 to be 1. So that should give me W2 as 1, so that 1 plus 1 is equal to 2. So I will assume these values. That's quite logical, simple, because 1 plus 1 is 2. So if you have to sum two numbers and get 2, the simple assumption that you can do is 1 plus 1 is equal to 2. So I'm going to substitute that here in the second equation. So what I will get is, W1 is already 1, so I'll get epsilon 1 plus W2 is also 1, so I get epsilon 2 is equal to 0. So that gives me epsilon 2 in terms of epsilon 1. Epsilon 2 is equal to minus of epsilon 1. So that gives me this equation. I'm going to take this equation and substitute it in the third equation. So what is that I'm going to get? If I take that equation and substitute it in the third equation, I get epsilon 1 square, because W1 is 1, and epsilon 2 is equal to minus of epsilon 1, so I get plus epsilon 1 square, because epsilon 2 is minus epsilon 1, and that should be equal to 2 by 3. So this gives me 2 epsilon 1 square is equal to 2 by 3. So I get epsilon 1 is equal to plus or minus 1 by root 3. I'll consider the plus sign. If I consider the plus sign, that should give me the value of epsilon 2 as minus 1 by root 3. Again, just take this value of epsilon 1 and plug it here to get epsilon 2 as minus 1 by root 3. So now I know that if I want to integrate this equation, I can just, so maybe in the next page I can just write this steps. If I have to integrate between the limit minus 1 to 1, the function a0 plus a1 epsilon plus a2 epsilon 2 square with respect to d epsilon, if I just have to integrate this, so I will not do by actual integration method. So what I will do is I'll just use Newton's, I'll just use numerical integration method, which states that you can write this integration as W1 F1 plus W2 F2 plus W3 F3 plus so on and so forth. Okay, so that's the result, because you know that if you just plot it as a graph, for this, if you just plot it as a graph, and if the graph goes like this and you have to integrate from minus 1 to 1, all you do is this integration, the sum of all the rectangles, and this is W1, this is F1, this is W2, and this is F2, and this is W3, f3, so on and so forth, right? So the question now is how many w's and how many f's that you have to consider. We know that for 3 terms you have to consider consider at least 2 points, the 2 Gauss points. We call that as 2 Gauss points. So that I will be left over with the w1 f1 plus w2 f2. So I can chop these terms because I know that if I consider the first 3 terms, I just need only 2 Gauss points. We call that as Gauss points. Okay, if that is the case, so we know w1. And what is f1, by the way? F is a function, and the function is f of epsilon is equal to, we know what the function is. It's a0 plus a1 epsilon plus a2 epsilon 2 square. Look for red color because this is at f1. It will be at epsilon 1 epsilon a0 plus a1 epsilon plus a2 epsilon square. This is epsilon 1. Okay. Similarly for f2, for this point you will be getting a0 plus a1 epsilon 2 plus a3 epsilon 2 square. So it's all 2 because that's the value of the function f2. So you see that you can just get the result of this integration by adding all the rectangles. So it's a perfect logic. The height of the rectangle is given by these fellows here. f2 is given here, and if you want f3, you can just write it f3 here. It's a0 plus a1 epsilon 3 plus a2 epsilon 3 square. All right then. So what is the value of f1? So I can just write what is the value of f1. f1 is a0 plus a1 epsilon 1 plus a2 epsilon 1 square plus w2, which is w2 into f2, which is a0 plus a1 epsilon 2 square plus a3 epsilon 3 square. And okay, so we know the value of w1, which is 1, so I'll keep it as it is. We know the value of epsilon 1. You computed the value of epsilon 1, which is plus 1 by root 3. It's plus 1 by root 3. And the value of into a1. So I can say it's a1 plus a2 into epsilon 1 square. So epsilon 1 square is 1 by 3. And similarly, the value of w2, it's going to be 1. The value of a0 is just a0 plus a1 into epsilon 2 square, and the value of epsilon 2 is minus 1. So anyway, since you take the a0 plus a1 epsilon 2, epsilon 2 is minus 1 by root 3 into a1 plus it's epsilon 1 epsilon 2, it's just epsilon 2, my mistake, plus a3 into epsilon 3 square, which is 1 by 3. Okay, now once you know the values of a0, a1, a2, I invite you to assume the values for a0, a1, a2, a3, right? It's a0, a1, a2. I'm making a lot of mistakes, I'm sorry. So once you assume the values of a0, a1, a2, you get the result for this integration. But for now, since I don't know the values of a0, a1, a2, I can just stop it here. But once you know the values of a0, a1, a2, you can just sum it up and get the answer. So in the practice problems, in the next session, we are going to solve a few problems. And amazingly, you will see that the value that you get by this method of integration and the value that you get by the actual integration by Newton's method, both the values will exactly be the same. Okay, so now you know that as the number of terms in the function that you consider keeps on increasing, you may have to take more number of weights, more number of Gauss points. So that is given by the equation. The number of Gauss points, which is m, is given by the equation, the order of the polynomial equation plus 1 divided by 2. So in this case, if the order of the polynomial, in our case, see here it's 2, right? So the number of Gauss points that you have to take is m is equal to n plus 1. N is the order of the polynomial, divided by 2. So 2 plus 1, 3 by 2, it's 1.5. So approximately you have to take 2 Gauss points in the next one. Okay. So this equation, this simple equation tells you how many Gauss points that you have to take, because there is a pattern that emerges. It's an emerging pattern once you solve for sufficiently higher order polynomials. This is the pattern. So you know that for one Gauss point, so far what we have done so far is the number of Gauss points. If m is equal to 1, then the value of W1 is equal to 2, and there is no epsilons, okay? And if the order of the polynomial, if the number of Gauss points, if you have to take 2 Gauss points, then the value of W1 is equal to 1, and the value of W2 is equal to 1, and the value of epsilon 1 is equal to plus 1 by root 3, and the value of epsilon 2 is equal to minus 1 by root 3. We just derived it. Similarly, if you have m is equal to 3, you will have 3 values for W, and you will have 3 values for epsilon. So there is a table that I'm going to project now. You can see the values now. So if the number of Gauss points, if it is 1, then W1, which is Q1, in this case here it is denoted as Q1, which is 2, and epsilon 1 is 0. So if the number of Gauss points, if it is 2, then W1 and W2 is equal to 1, and we found that epsilon, you can call this as epsilon 1 and this is epsilon 2, really doesn't matter, okay? Either way it's going to work perfectly fine. And the value of, if you have 3 Gauss points, you can have the value of epsilon 1 is minus root of 3 by 5, epsilon 2 is 0, epsilon 3 is root of 3 by 5. And the value of W1 is 5 by 9, W2 is 8 by 9, W3 is 5 by 9, so on and so forth. So if you have this table, you can just, instead of doing the integration by conventional method, what you can do is you can just integrate any function by simply writing it as W1 F1 plus W2 F2, so on and so forth. And you know, F1 can be any function in terms of epsilon, and all you have to do is epsilon 1, epsilon 2, epsilon 3, so on and so forth. Now this is going to be amazing when it comes to complex integrations, okay? So in the next video we are going to solve it, but suppose if you are asked to solve between minus 1 to 1, say for example epsilon plus 2 epsilon the whole cube divided by epsilon square, and if you are asked to integrate this function, it's very difficult, right? It's quite involved to do by Newton's method, but here you can just say W1 plus F1 plus W2 F2, so on and so forth. All you have to do is for F1 you simply substitute epsilon 1 plus 2 epsilon 1 divided whole cube divided by epsilon 1 square. You know the values of epsilon 1, so all you have to do is plug those values of epsilons. Simple addition and multiplication that you can do using your calculator and get the result. Hope you find this video useful. This is just to get across the concept of numerical integration. Just peruse the concepts, and hope this will be useful. Thank you all for your patience. I really appreciate your time. Thank you so much.